Hello dear students, welcome to the video lecture series created under Professional Learning Community of Walchand Institute of Technology, Solapur. I am Sanjivkumar Siddul, working as an assistant professor in physics under the Department of Humanities and Sciences, Walchand Institute of Technology, Solapur. In this video lecture, we will study the second part of Introduction to Nanoscience. These are the learning outcomes of this video lecture. By the end of this session, students will be able to get acquainted with the classification of nanomaterials based on their dimensions. Student will be able to learn about different types of nanomaterials with variety of examples. These are the contents of this video lecture. Classification of nanomaterials. Students, can you recall what are nanomaterials? Yes, nanomaterials could be defined as those materials which have structured components with size less than 100 nanometer at least in one dimension. Now, based on how many dimensions of the structured components are less than 100 nanometer, the nanomaterials are classified into four different categories: zero-dimensional nanomaterials, one-dimensional nanomaterials, two-dimensional nanomaterials, and three-dimensional nanomaterials. Let us explore each category of nanomaterials with different examples. The first category of nanomaterials is zero-dimensional nanomaterials. Zero-dimensional nanomaterials are the one which are confined in all its three dimensions. That is, its three dimensions, length, breadth, and thickness are less than 100 nanometer. Hence, these materials appear like particles, grains, shells, dots, etc. Some of the examples of zero-dimensional nanomaterials are as follows. The first example of zero-dimensional nanomaterials is nanograins. A nanograin refers to a grain or crystalline domain in a polycrystalline material that has size in the nanometer range, typically less than 100 nanometer. Here are the images of palladium nanograins obtained by high-resolution transmission electron microscopy. The second example of zero-dimensional nanomaterials are nanocapsules and nanospheres. Here we have schematic diagrams showing how nanocapsule and nanosphere look. Generally, these nanocapsules and nanospheres are made of polymetric membrane and polymetric matrix respectively. In these, small molecules or drugs are encapsulated. Nanocapsulation is the effective way of delivering drug to disease-specific sites, reducing the toxicity of drug to other tissues. The next example of zero-dimensional nanomaterials is quantum dots. A quantum dot, also termed as QD, is a semiconductor nanocrystal that exhibit a unique optical and electronic property due to quantum confinement effect. The sizes of quantum dots typically range from 2 to 10 nanometers. Here we have the transmission electron microscope images of indium arsenic quantum dots grown over gallium arsenic substrate. One of the most famous example of 0D nanomaterials is fullerene. Fullerene is a unique symmetrical allotropic form of nanocarbon. It is a spherical structure made by arranging carbon atoms in regular polygonal, that is, pentagon and hexagon structures. The second category of nanomaterials is one-dimensional nanomaterials. One-dimensional nanomaterials are the one which are confined in its two dimensions. That is to say, breadth and thickness of these materials are less than 100 nanometer. Hence, these one-dimensional nanomaterials appear like tubes, wires, filaments, etc. Some of the examples of one-dimensional nanomaterials are as follows. The first and most prominent example of one-dimensional nanomaterials is carbon nanotubes, which are also referred as CNTs. Carbon nanotubes can be considered as cylinders made up of tiny graphite sheets of 1 atomic thick. These tubes are mostly closed at the ends. CNTs have unusual thermal, mechanical and electrical properties which make them ideal for a wide variety of applications. Carbon nanotubes are currently revolutionizing many fields including nanotechnology, personalized electronic wearables, optics, electronics and other fields of material science and technology. Nanorods are the second well-known examples of 1D nanomaterials. Here are the transmission microscopy images of gold nanorods. The gold nanorods are obtained in various sizes and shapes. The image A shows gold nanorods with spherical heads, while the image B shows dog-bone-like gold nanorods. Gold nanorods have attractive applications in biomedical technologies, spectroscopies, and optical and optoelectronic devices. The next example of 1D nanomaterials is nanowires or nanofibers. They have been studied extensively for their potential benefits in tissue scaffolding, drug release, and specifically in wound dressing. Here is a scanning electron microscopy image of nanofibers of polyvinyl pyrrolidone. Another example of 1D nanomaterials is nanofilaments. Nanofilaments are 1D nanomaterials with diameters of several tens of nanometers and maximum lengths approaching the millimeter scale. This is a scanning force microscopy image of one-dimensional silicon nanofilaments. The third category of nanomaterials is 2D nanomaterials, that is to say, two-dimensional nanomaterials. These are the nanomaterials whose only one dimension, that is to say, only thickness, is confined to nanoscale. That means these are flat planar materials having thickness less than 100 nanometer. So they appear like discs, plates, films, etc. Few examples of 2D nanomaterials are as follows. The first and most famous example of 2D nanomaterials is nanofilm. Nanofilms are ultra-thin films with thickness in the nanometer range, typically less than 100 nanometer. They are often used to modify the surface properties of materials without significantly altering their bulk characteristics. They can be single-layered or multi-layered. Here is a cross-sectional image of hafnium zirconium oxide nanofilm carefully grown on silicon. This image is taken using transmission electron microscope. The second example of two-dimensional nanomaterials is that of nanoplatelets. Nanoplatelets, shortly called as NPLs, are two-dimensional nanostructures with thickness typically of a few nanometers and having lateral dimensions of few tens of nanometers. Another example of two-dimensional nanomaterials is of nanorings. Nanorings are nanoscale ring-shaped structures formed by self-assembled nanoparticles or nanowires. They are typically a few nanometers to a few hundred nanometers in diameter and have applications in nanophotonics, catalysis, sensing, and biomedical fields. Here are the images of gold nanorings taken by scanning electron microscopy with different magnification. The next example of 2D nanomaterials is nanodiscs. Nanodiscs are soluble nanoscale lipid bilayers formed by a self-assembly process. Nanodiscs are widely used in biomedical research, plasmonics, electronics, and catalysis. Here, figure A is an illustrative image of phospholipid nanodisc and figure B is a negatively stained electron microscopy image of nanodiscs prepared using the membrane scaffold proteins. Yet another example of two-dimensional nanomaterials are superlattices. A superlattice is a periodic structure composed of alternating layers of different materials or nanostructures. These layers have thickness ranging from a few atomic layers to several nanometers. Superlattices are widely used in semiconductors, photonics, quantum devices, and thermoelectric. Here are the TEM images of binary superlattices self-assembled in the presence of oleic acid and tri-N octyl phosphine oxide. The next fourth category of nanomaterials is three-dimensional nanomaterials. 3D nanomaterials are finite sized materials that are composed of nanoscale building blocks. One of the famous example of 3D nanomaterials is of aerogels. Aerogels are ultra lightweight, highly porous nanomaterials formed by replacing the liquid in a gel with air while maintaining the solid framework. Aerogels exhibit exceptional thermal insulation, low density, high surface area, and mechanical strength, making them useful in aerospace, energy, electronics, and biomedical application. Here, image A shows typical silica aerogel monoliths with different shapes and morphology. Figure B shows micron-sized silica aerogels, while figure C shows TEM micrograph of the typically interlinked structure pattern of a silica aerogel. Another example of 3D nanomaterials is of metal organic frameworks, also called as MOFs. MOFs are highly porous crystalline materials composed of metal ions or clusters coordinated with organic linkers. This hybrid structure forms 3D networks with exceptional surface area, tunable porosity, and chemical versatility. MOFs are widely researched for applications in gas storage, catalysis, drug delivery, sensors, and energy storage. The next example of three-dimensional nanomaterials is pillared graphene. Pillared graphenes are hybrid nanomaterials that consist of graphene sheets spaced apart using molecular pillars such as carbon nanotubes or other nanostructures. In near future, these nanostructures will have a wide applications in the branch of storage of the hydrogen fuel. Now students, try to answer the following MCQs. Here are the answers indicated red in color. These are the references used. Thank you.